Okay, the topic that we are looking at today in physics of S2 is work, power, and energy. I'm sorry for the year has to be 2024. I hope you have everything that you need for the lesson, and we are going to get the lesson started as soon as possible. In case you get any question as we proceed with our lesson, you are going to raise up in the chat, and if there is any hand for a question, then we will proceed. My name is Peter Nsubuga, and I'm going to be taking you through the lesson for today. Okay, I've told you the topic is work, power, and energy, and it's for physics, and you must be starting your S2 2024. Let us start with work. From what you see on your screen, they are telling us that in physics, work is done when the force acts on an object, and then when the force is acting on that object, it causes that object to be displaced. In other words, it changes the position of an object. And therefore, they have given us a definition for work. And I would like one of you to raise up your hand and you read for us that definition as you see it on your screen. Isaac, your hand is up. You read for us.
Work is defined as the product of force and distance moved in the direction of force.
Yes, we are defining work done or work as the product of force and the distance that is moved in the direction of force. So if you apply a force on a material or in something, and that thing moves a certain distance, then you have done some work. If you apply a force on any item or any material or anything, and that thing does not move any distance, then that there is no work done. So work is only done if a force moves an object through a certain distance. That is how we define work. Work, you have to move a certain object through a certain distance. So we define work as the product of force and distance moved in the direction of force. And the SI units, the units that we use for force are joules, and joules is a capital J. So that is the first thing that we are learning today in our lesson. But as we continue, I will ask you please to use the chat properly, such that the messages that go in the chat are those ones that are helpful in our lessons. I want us to focus. We first study we will do the introductions maybe later in the lesson. For which school do you come from? Who are you? What is your other name? So those ones we'll do them after the lesson. Let us first study. Then we'll get to do those ones later. So the first thing you should note that work is the product of force and distance moved in the direction of force. And that the SI units for work done are joules. And I want someone to read for us that scenario that we have by show of hands. Antonia?
Romeo and Rafa are siblings. They are told to push a box through a corridor which is 4 meters long. Rafa uses a force of 80 newtons and moves the box through 2 meters in 4 minutes, while Romeo uses 60 newtons for 10 minutes, but the box was not displaced. Who of the two should not be rewarded and why?
Okay, thank you, Antonia, for that. So let me receive the answers in the chat. Let me have the answers in that. Who do you think will not be rewarded and so put someone who should not, you also put reason why. Okay, from the chat, I have many answers of Romeo not being rewarded because people are saying he has not done any work. He has not done any work. The reason why we are saying that he didn't do any work is because this person did not displace the box. And we have said that for work to be done, a force must cause an object to move through a certain distance. The force must cause an object to move through a certain distance. So it means that since this person didn't cause the box to move, then there is nothing to give that person. Okay, we have examples here. We have examples. We have an example that says that Jane pulls a goat which is resisting to move through a distance of 5 meters using a force of 60 newtons. They are telling us to calculate the work done. Now they have given us distance D as 5 meters, and they have given us a force F as 60 newtons. So they are asking us for what is the work done. Remember, from definition, we said that work done is the product of force and distance moved in the direction of force. That means that our work is going to be equal to the 60 newtons times the 5 meters, and our work will be 300 joules. The work done, according to that first example, will be 300 joules because they gave us distance as 5 and force as 60 newtons. Okay, the second example. What do you think? Answer. We should read the second example. Try to calculate which answer do we get. They're telling us B and town C 200 and 500 meters away from town A respectively. From town A to B before reaching town C. If its engine does work of 1.5 million joules from B to C, then they want us to get the force of the engine. So according to you, what will be the driving force? according to what we have, we have distances and we have work done. So they are asking us for the force. So what we are going to do, excuse me. What we are going to do is to first have a sketch. They have told us we have town B, town C, and town A. Let me start with A. So we have town A, town B, and town C. So they are telling us from A to C is 500 meters, and from A to B, it is 200 meters. So they want us to find the force given that the work done here, is equal to 1.5 million joules. So that means for us to get the 1.5 million joules, we have to get force times the distance, which is now, if from A to B it's 200 and from A to C is 500, then I think from B to C will be 500 minus the 200, which will give us 300 meters. So we'll be having F times 300 is going to be equal to 1.5 million. So we'll be having something like that. So that means at both sides of our equation, we are going to be having we are going to be having 300 of F being equal to 1.5 million. So it through by 300, our F as by 3.1, then by 3.5. So we are getting our answer as 5,000. We are getting our answer as 5, 0, 0, and a 0. And those ones, because it is force is always in newtons. So we'll be having 5,000 newtons, our answer. Hope we are all together.
Yes, sir.
Okay. So after those examples, first look back against gravity. The work that we have been talking about of force times distance, most of it is horizontal. But there is work done against gravity, and that work done against gravity is vertical. Vertical means it acts from up coming down, or from down going up. Whereas if someone says horizontal, it means that it comes from left going to right, or from right going to left. Can someone read for us what we have on our screen? Yes, Bernice?
When a body is carried vertically upwards through a distance above the ground, work is said to be done against gravity. For example, if a person climbs stairs or if a body is pushed up an inclined plane, we calculate work done against gravity from work is equals to weight times distance, where weight is products of mass of a body and acceleration due to gravity.
Okay. Thank you for reading for us. They have told us that when a body is carried vertically upwards through a distance, then we say work is done against gravity. If a person is climbing stairs, that is one. Or if a body is pushed up an inclined plane, then that body is said to be, or work is said to have been done against gravity. Anything that they say against gravity, that means it is opposing the gravitational force. We are trying to bring something down, it begins to be up always. We want to push something up, then it wants to remain down. That is because of gravity. But if work is being done against gravity, that means we are opposing the gravity. For example, if you are moving a body up an inclined plane, that is one. Then the second, if a body is climbing, if a person is climbing stairs, that is the second one. So if someone talks about work done, then that one is force times distance. If someone talks about work done against gravity, then we'll use weight times distance moved vertically upwards. So after getting that, we can continue. If you're trying to put down the notes, you can screenshot the screens that you have so that you can be able to refer to your work at any other time. Or what you do is once the thing gets started, once a slide gets started, you just summarize the important points in that slide such that you can be able to refer to them after the lesson. So let us write down those examples. Then I come and we go through them. Let us put them down. All right. Let us see. Let us go through the first example. The first example says that Ruth has to attend a physics practical lesson in the lab. This person has to attend a physical practical lesson in the lab. She climbs up a staircase of height 5 meters. So this person climbs up a staircase and the height of that staircase is 5 meters. So if Ruth has a mass of 60 kilograms, if this person has a mass of 60 kilograms, they are telling us to calculate the work done. Now remember, we said that if it's a vertical distance that has been moved, then work done has to be weight, and weight is got from mass times acceleration due to gravity, then times the distance. So let us first summarize what we have. We have the height, we have the mass, and we have the acceleration due to gravity. So we are going to use them to get the work done. Now, remember, they have given us 3 things. They have given us distance of the staircase or the height of the staircase, which is 5 meters. They have given us the mass of this person, which is 60 kilograms. And they have given us G, acceleration due to gravity, which is 10 meters per second. Now, what happens is we are going to first note that for us to get work done, we get it from force or weight times distance. The weight is 60 times the acceleration due to gravity, which is 10. Then our distance will be times 5. So if you calculate, you'll be having 600 times 5, which will give us 3,000. 3,000, and 3,000 is going to be in joules. So the reason why we have multiplied 60 times 10, because the 60 was a mass and we had to make it a force. So let us see, that is the answer for the first question that we had, 3,000 newtons. So for those taking screenshots, you can take screenshots now, and we see how to do number 2. Yes, Augustine. Sorry, Austin, you have a question. Austin, you.
Sir, you say that work is measured in joules, but here you're saying that the answer is 3,000 newtons. How come? Yet you had said that work is measured in joules. Sir.
Austin, newtons are for forces. Work done has to be in joules. So please, you correct that.
Thank you, sir.
Okay. We are going to look at our second question. Okay, our question is, let's see if we get it out. Let's try our second question. Angela, teacher, number 1. Someone was saying pardon on number 1. Now, number 1, if you look at it, they have told us, or they have given us height or distance. They have given us mass of this person, and they're asking for work done. Now, my dear, there's no way we get work unless we know the force and the distance. And for us to get the force in this case, we must change this mass, which is 60 kilograms. We must make it a force, or we must make it a weight by multiplying it by the acceleration due to gravity. So for us to get the work done, for number 1, we will get the 60, which is the mass, times 10, which is acceleration due to gravity. That one has given us the force. Then we multiply by the distance this person moved, which is 5 meters. And that will be giving us our weight as 3, so our work done as 3,000 joules. That is for our number 1, for the person that asked what was number 1 about. Then for number 2, Bernice, what is the problem? Please don't stay with your confusion. You write your question in the chat such that we can be on the same page. We are doing number 1 for now. Bernice, where is the confusion coming from for number 1? You can raise your hand and we unmute you and you ask your question. I don't want you to stay confused. Yes, Nora, your hand is up.
So I was wondering, on number 2, if we are supposed to get the force, are we supposed to use the same acceleration due to gravity as number 1?
Yes, acceleration to gravity is the same. It's constant. Now we are going to know, because as a correction, even have to number 175 that they pass has to use. So you correct that. This one here must be in use before you calculate, because work done has to be in use. You correct that before you start working. This one here. This one here is in use. So we have number 2. They are telling us we have a box of weight 500 newtons. Now for number 2, we don't even have to bother with the acceleration due to gravity, because our weight is already in newtons and is pushed up an inclined plane. If work done in pushing the box is 1,375 joules, that one has to be joules because it's work done. Then they are asking us to get the height of the incline.
Recording in progress.
Now, number 2, telling us box of 550 Newton, it is put up in plane. They're asking us the work the 1 3 and 5 Newtons. They're asking us to get they're asking us to get the height of the inclined plane. So to work with what we already know is that if we have work done, remember we said that work done is force times distance. They have given us our work as 1375. They have given us force as 550, but they have not given us the distance. So if we divide 550 on both sides, then our distance that we get D, if you have a calculator, will be 2.5, and it will be in meters. It will be 2.5 and it will be in meters. So that is the what we are going to have. Hope we are all at par at that. And now what is the problem that we should sort out? Because I don't want to leave anyone behind. Okay, someone is saying the explanation wasn't clear. They had given us work done as 1,375, and they gave us the distance, sorry, the force as 550 newtons, and they wanted us to get the distance. So in our formula of work is equal to force times distance. We put 1,375 where there is work, and 550 where there is force, and the distance will remain d. So if we divide through by 550 on both sides, we are going to have our answer of d as 2.5 meters. So that is what I was saying. I was trying to tell you. Okay, so let us continue with our lesson if all of us are okay with work done.
Yes.
All right. We are continuing with our lesson, and we are now proceeding to work done. Now, according to what we have on screen, we are now looking at power, because our topic is work, power, and energy. And now we are looking at power. Now, in our document that we have, they are telling us that if two people, P and Q, carry a load of 50 newtons through a distance of 10 meters, we say both of them have done the same work. That is, if they have carried the same load through the same distance. But if P did this work in 20 seconds and Q did this work in 40 seconds, it means that Q took more time than P. So if that one happens, we will say that P is more powerful than Q, because P uses less what? Time. For example, if you are home, you and your sibling, and they tell you to carry a 20-liter jerry can, from one place to another. And for you, you carry it maybe in 2 minutes, then your brother carries it in 10 minutes. We will say that you are powerful than your brother because you have done your work in less time. So it means that when we talk about power, we are bringing in the element of time. And how do we bring in the element of time? We define power as the rate of doing work. How much work do you do in a specific time is what we call power. Power is the rate of doing work, and it is measured in watts. The SI unit for power is watts. So someone can ask, then how can I find power in calculations? Because we have seen that there is an element of time in power, and they are telling me power is rate of doing work. If someone says rate, it means how much do you do in a specific time? What do you do in a specific time? How much work do you do maybe in a second? That is power. How many jerry cans can you carry in 1 hour? That is power. So it is the rate at which you do work that we define as power, which is got in watts. So the formula for power has been given to us here. It has been given to us that power is equal to work done divided by the time that is taken. Work done divided by the time that is taken. So if someone tells you to calculate power, then you have to get the work done, because we have seen that work. First, we said work is force times distance, and then we divide it by the time taken. And that time when you are working must be in seconds. Power must be got in work done, which is in joules, and time must be in seconds. So let us have some examples. We start with example 1. Reads. Can someone read for us example 1? Mary Blessing.
Calculate the power developed when a force of 50 newtons acts through a distance of 3 meters in 2 seconds.
Okay. They are telling us to calculate the power that is developed when a force of 50 newtons acts through a distance of 3 meters in 2 seconds. And now remember, we Remember, we start from looking for what, please don't do the annotations on my screen. Okay. They have given us the force as 50 newtons, the distance as 3 meters, and the time as 2 seconds. And they want us to get the power. Therefore, we are going to say that for us to get power, power is going to be equal to the force, then times the distance, d, then divide by the time, t. Remember, I've told you force has to be newtons, distance must be in meters, and time must be in seconds. So according to the question that we have, they have given us a force that is 50 newtons. They have given us a distance that is 3 meters. So we are multiplying by 3 meters. Then they have given us a time of 2 seconds. So if you have your calculator, I'm sure you will be having your answer as here we'll be getting 150. Then we divide it by 2 to get 75. And remember, they told us that the answer we are getting has to be in watts. And watts is a capital W. So every one of us has 75 watts, most of us, and that is our answer. For question 1, let us look at question 2. Question 2, they are telling us that we have this person, Tom, who uses a power of 600 watts to climb up a staircase of 6 meters in 5 seconds. So they're asking us, what would be the reading in newtons? So they're asking for the force if Tom stepped on a weighing scale. So they are asking us to get the force or the weight of Tom. And for us to get the weight of Tom, it's as simple as getting the weight. Is there anyone who can take us through this question to show us the answer? By show of hands. Yes, Raj.
Yes. So Tom uses power of 600 volts to climb up a staircase of 6 meters in 5
Yes.
seconds. What would be the
Yes.
reading in newtons on a weighing scale if Tom stepped on it? So what they want here is to calculate the force or the weight. So in yeah, sorry. So in this case, I think we have to divide. So I think 600 volts divide by, and we'll multiply 6 meters times 5 seconds, which we will get 30. And then 600 volts divide by 30, we get 20. So I think 20 newtons.
Oh, Raj, you wait. I'm going to make you. I'm going to give you host rights so that you can show that to us. Because I want us to see it while you are doing it.
So like, is it okay if I can share my, like, what should I do? Like, share my screen and
Yes,
then
you
I
share
see the
your
whiteboard.
you share your screen. You share a
Sir,
whiteboard.
could you please? Yeah. Yeah, so I hope you're able to see my screen.
Yes, it can be visible.
Okay, so what we need to calculate here is the force or the weight. So what we'll do here is that since we need to get the force or the weight, so we'll say force is equal to these are the 600 600 volts, meaning the power, and then we divide this, and into brackets we say the 5 meters times 6 seconds. So the force will equal to 600 divide by 30 into brackets newtons, because force is weight, and weight, the main SI unit for weight is newtons. So force will equal to 20 newtons. That's it, sir.
Okay, thank you, Raj. You can stop sharing so that I can share my screen.
Just a moment.
Raj has got 20 newtons. Thank you so much. Some other person has a different answer. Let us see. Let us use this C formula that we have used here, and we see which answer we will be getting. If it's the same as that one of Raj. Raj, thank you so much for that answer. Okay. So they gave us the power as 600 watts, and they want us to get the force, but they have given us the distance as the distance is 6 meters and the time is 5 seconds. So we are going to put the 6 where there is distance, and we are going to put the 5 seconds where there is time. So we are going to be having 600. Then we are going to multiply it by the 5 because these two we can cross multiply them. Then it will be equal to 6 times f will give us 6f. So after that, we are going to have 6 times the 5, 600 times 5 will give us 3,000. And 3,000 is going to be equal to 6f. So what we are going to do there is to divide through by 6 and divide through by 6. So if you divide through by 6, you get your answer as 1 by 6. We'll be getting our answer as 500. And since it's a weight, it will be in newtons. So our answer is going to be 500 newtons. Let us all correct that. Answer is 500 newtons. I think we can all see where it came from. Okay, are we all at par? If we are all there, then we can let us put down these questions. We are going to try them out. And see the answers that we get. Let us first write down the questions. Question 1, question 2, question 3, and we are going to copy question 5. You eliminate out question 4. You may not copy it, but let us copy 1, 2, and 3 for now.
All right, hope we have copied the questions. All of us. Now there is another question that we have to copy. It's number 5. So let us copy number 5 too. And after copying number 5, I will let you do your please, number 4, we are not going to copy it. We are doing number 1, 2, 3, and number 5 only. We are not going to do number 4. All right, now I'm going to give you the time such that you do those numbers that we have put down without hurrying. You do them in your time. You take your time to do them such that the next time we meet, we first look at them and then we continue with our topic. I think in the next lesson, we will be looking at energy. And after doing energy, we'll continue and look at machines if we still have the time. But as for today, you will allow me stop here. I thank you all who attended. We will meet again, I think on Tuesday of next week. I will request one of you who is still around to pray for us, and then we continue. And then we leave, sorry. One person to pray for us, and then we go. Sasha. Sasha?
Yes.
You pray for us, and then we leave.